Hello computational thinking students. In this tutorial we will see pseudocode for lists and dictionaries. This is the outline of this tutorial. List ++ operator, list functions, followed by insertion sort, dictionary functions, and difference between index and key at the end. Let's see what is list. List is a collection of values stored in a sequential order. List can store values of different data types. List can store duplicate values, which means a same value can exist multiple times in a list. List preserves the order of elements in it. This is one of the most important concepts with respect to list. An element in a list can be another list or a dictionary, which means a list can store other lists or dictionaries, generally referred as list of lists or list of dictionaries. List is initialized using opening square bracket followed by closing square bracket notation. Variable L is equal to opening square bracket followed by closing square bracket, or length of L is equal to 0 denotes that the list is empty. ++ operator. ++ is a special operator used to operate over lists. List is equal to list ++ list. This indicates that ++ operator has two operands, and both those operands has to be lists. ++ operator is used for two different operations, append and extend. Now let's see the difference between append and extend. When we want to merge the elements of two different lists into a single list, then this operation is called as append. For example, if L1 is equal to 1, 2, 3 and L2 is equal to A, B, C, then L1 ++ L2 will result into 1, 2, 3 immediately followed by A, B, C. Here all these 6 elements will be in a single list. Next is extend. Extend is the operation extends or adds one more element inside the existing list. For example, L is equal to 1, 2, 3 and X is equal to 4. Then L ++ X inside square bracket notation will give us 1, 2, 3, 4. Same extend operation can be performed by interchanging the operands of ++ operator, as given in the second example. Variable X inside list notation ++ L will give us 4, 1, 2, 3. The change in the resultant list is only because of the sequence of operands of ++ operator. As we have seen earlier, list preserves the sequence of its elements. While doing extend operation, we have to be bit more careful. L ++ X or X ++ L are incorrect statements because X is an integer variable, not a list. To avoid this problem, we have enclosed variable X inside list notation. It is required because of the first point, which says ++ operator requires list operands. Let's see some more examples of list using plus plus operator. For example, L is an empty list. L1 contains 1, 2, 3 and L2 contains A, B, C. If we perform this operation, L is equal to L plus plus L1 inside square brackets, then L will result into a list of list, and that inner list will hold 1, 2 and 3. If next operation is followed by the list operation, then we will add one more element into list L, which is another list, and that list will contain A, B and C. As you can see over here, we have created a list of lists. The outer list contains 2 elements, whereas each inner list contains 3 elements. This particular list of lists got generated because we enclosed L1 and L2 inside square brackets, even though L1 and L2 were lists. Now let's see how to add a dictionary inside a list. With this example, we will try to create a list of dictionaries. For example, L is equal to empty list, D1 is equal to a dictionary which has these pairs of values 1, 1, 2, 4, 3, 9, which represents the squares of each number, and D2, small a, capital A, small b, capital B, small c, capital C. L is equal to L plus D1 enclosed in a list notation. Then our resultant list will have a dictionary inside it, as shown over here. If we also add D2 in the same manner, then the resultant list will hold 2 dictionaries inside it, and each of those dictionaries will have 3 values in it. This particular structure of list of dictionaries was achieved because we added those dictionaries D1 and D2 as a single element using list notation. Moving on to list functions. This particular table represents all list functions executed using different sets of inputs. The first column represents all different types of inputs, and the rest of the table shows what will be the equivalent output for the given input. Let's see the given table row by row. If the given input is an empty list, then the output of length function will be 0 and the return type an integer value. First of empty is always undefined. Last of empty is also undefined. Rest of empty is empty list itself, and the return type is list. Similarly, init of empty list is also empty list, and the type is list. Second input. If we give an input list with only one element inside, then length function will return 1, which is an integer. First of L and last of L both will give that same value, which is 10 in this case, which is again an integer, whereas rest and init will give empty list and type will be list. In case of third input, now we have 4 elements in the list. Hence, length function will return 4, which is an integer. First will give 1, last will give 4, because those are the first and last elements of the input. Rest function will return a list with 2, 3, 4, because it returns the entire list except the first element. Init will return 1, 2, 3, because this function returns all the elements from the original list except the last element. Similar thing will happen in case of fourth input. But here if you see, the return type of first and last function is different. Earlier it was returning integer, but now these two functions will return string because the elements inside the list are strings. Next input list is a combination of integers and strings. Still, the length function returns an integer value which is 6. First of L is 2, which is an integer. Last of L is A, which is a string. Rest of L will return the entire list except the first element. Init will return the entire list except the last element. Next input is a list of lists. Now over here length function is returning 3 because the outer list contains 3 elements inside, even though each element is a list itself. First function will return the first element from the outer list, which is a list. Hence, first of L will give us a list which contains 1, 2, 3. Last of L will give us the last element of the input list, which is a list itself in this case. Hence, the output of last of L will be 1, 8, 27. Rest will return all the existing elements of input list except the first element. Hence, that entire inner list will be removed. Same thing will happen with init function, but over here the last element from the input list will be removed. Next input is a list of dictionaries. Still the length function will return an integer value which is 2 because the input list contains 2 elements irrespective of the type of those elements. Rest will return a list of a dictionary because it removes the first element from the input list. Similar thing will happen with init function. It will remove the last element from the list, but still the output is list of a dictionary. Last input is a combination of previous two inputs where we have created a list which contains first element as a list and second element as a dictionary. Still the length is 2, which is integer. First of L will return a list, whereas last of L will return a dictionary, because that's how our input is given. Now rest of L will give a list of dictionary, whereas init of L will give list of list. If we analyze the column of each function, we can come to a conclusion about the return type of each function. Length always returns integer. Here first function sometimes returns integer, sometimes string, sometimes dictionary, or even a list. Based on this information, we can conclude that the return type of first function depends on the data type of elements inside list. The first element inside list will have some specific data type. That same data type will be used by first function as a return type. Same thing will happen with last of L. Only difference being, instead of the data type of first element, last function will consider the data type of last element in the list as its return type. Now coming to rest and init functions. If we observe the outputs of those two functions carefully, you will see the return type is always a list, irrespective of the different inputs given. based on this entire information, we can conclude that length always returns integer, rest and init always returns list, whereas the return types of functions first and last depends on the given input. Now let's see how insertion sort works. Let's consider the given input list with these 5 elements: 5, 2, 1, 3 and 4. Then we will declare one empty list named sorted list. Over here we will try to insert one element at a time from input list to sorted list using the for each block over here. We will traverse over the input list element by element using variable x. Each time we come across new element in variable x, we will call a procedure insert an element with two parameters, sorted list and x. And whatever result the procedure insert an element returns will be stored back to a variable sorted list. This will make sure the variable sorted list is updated after every iteration of this particular loop. Now let's see the definition of procedure insert an element. Procedure insert an element SL, X is defined over here, and the table on the right illustrates each iteration executed in the main code as well as iteration happening inside procedure insert an element. Now the main code will pass the sorted list and one element from the input list at a time, which is stored in X. Over here we will declare one temporary list, which is an empty list initially. We will set one flag variable called inserted to false because initially the given element is not yet inserted. Whenever it gets inserted, we will change this particular variable to true. Now we will execute this for each block over the list SL element by element, which is stored in variable ELE, which represents nothing but one element at a time from list SL, which is the sorted list. Now let's try to execute this logic using the given input list. In the first procedure call, the sorted list or the variable SL will hold the empty list, whereas the value of x will be 5. Initially temporary list is empty, inserted is false. Now ELE, the variable element or ELE, will not be initialized because SL is an empty list, due to which for each block will not execute, and we will directly jump to the last if block, which is outside the for each block. Now at that particular point, variable inserted is still false. Now we are taking not of false, which will give us true. Now if true, we will execute the statement inside if block, which says temp list is equal to temp list plus plus x. Because of this particular statement, the element 5 will be inserted to temporary list. Then we will return temporary list back to the original procedure call, and the values of temporary list will be assigned to variable sorted list. Therefore, during next call, sorted list or SL variable will have one value inside it, which is 5. The updated value of x will be 2 because that's the next element in the input list. Temporary list will be re-initialized to as an empty list. inserted variable will be also reinitialized to false. These reinitializations are happening because we are starting the procedure insert an element again from the beginning. Now, as we have one element in the list SL, the for each block will execute and the first value for variable element will be 5. As you can see, 2 is less than 5. Therefore, the first if condition in for each block says not of inserted. Now, as inserted being false, the if condition will be true. Then we will move to next if condition. Here we are comparing the value of x against value of ELE. Now x is less than ELE because 2 is less than 5. Because of this, the next two lines inside if block will be executed. Templist is equal to templist plus x. Hence the value of templist will be updated to 2. And then the value of variable inserted will be changed to true. After the execution of these two statements, we will come out of the if loop, and the next line, which is templist is equal to templist plus variable ELE enclosed in a list will be executed, and this will add value 5 into temporary list. Therefore, the updated value of temporary list is 2, 5. Last if block will not execute because the variable inserted has been set to true and not of true is false. Same process will continue for remaining elements, which are 1, 3 and 4. At the end of the entire execution, we will have the sorted list, which is 1, 2, 3, 4 and 5 in the original code. Next point is dictionary. Dictionary is a collection of elements stored as key:value pair. Dictionary can store keys and values of different data types. Dictionary can store duplicate values, but keys must be unique, which means different keys can have same value, but same keys are not allowed inside a same dictionary. Dictionary does not preserve the order of elements in it. It allows us to have that random access to each key value pair in the dictionary. Due to this, we can access any element in the dictionary directly using a key. A value in a dictionary can be another dictionary or a list. Dictionary is initialized using open curly brackets followed by closing curly brackets notation. Dictionary value is accessed using D opening square bracket then key followed by closing square bracket notation. Now let's see the dictionary functions. Dictionary has two important functions, keys and isKey. Keys function returns the list of keys present in the dictionary. For example, if D is equal to A:1, B:2, C:3, then keys of D can return ABC or ACB or BCA or BAC or CAB or CBA because dictionary does not preserve order. Therefore, keys function can return the list of keys in any order. Hence, there is no way to predict exactly in which order this keys function will return the list of keys. isKey D, K function returns true if K is a key in dictionary D, else it returns false, which means This eachKey function checks if a particular key exists in the dictionary or not. If it exists, then it returns true, or else it returns false, as shown in the next two examples. If D is equal to A:1, B:2, C:3, and then if we execute eachKey function on this dictionary as eachKey D, A, it will return true because A is a key in the given dictionary. Whereas in second case, if we execute eachKey of D, Z, then it will return false because Z is not a key in the given dictionary. Let's see the difference between two concepts, namely index and key. The term index comes into picture only with lists, whereas the term key is considered only with dictionaries. Index indicates the position of the element in the list, whereas key is an unique entity used to identify its value in the dictionary. Index is always an integer starting from 0 to n. Key can be of any data type. Let's consider these examples to explain index and key even further. L is equal to 10, 20, 30, 40. Then index 0 is 10, index 1 is 20, and so on. Whereas in case of a key, let's consider D is equal to 1:10, 2:20, 3:30, 4:40. Then D of 2 will give us the value because the key 2 is associated with value 20. Thank you for watching this tutorial. Happy learning.